In this video we're going to design the side view and the top view of the aircraft. So far we've designed the cross-section of the airplane, and we're using that as the starting point to first make the top view of the aircraft. However, before we do that, we start with this blank A3 canvas of paper, and we need to think about how to divide this paper such that our 3-view drawing that is supposed to appear on this paper can actually fit on there. Now, to do that, we first need to estimate what the length of the fuselage is going to be and roughly what the span of the wing is going to be. In this video, we've already done that in preparation, because I'm using the exam from April 2019, where this division of different parts of the canvas has already been performed. So you can see here that here I'm going to draw the front view of the airplane, here I'm going to draw the top view of the airplane, and here I'm going to draw the side view of the airplane. And in order to make that fit, I need to divide my canvas into these boxes, and it says here that I need to be 90 millimeters from the side. So the first thing I'm going to do to mark off that box is to mark off 90 millimeters here. I'm drawing a dashed line down just to mark that, and from the bottom I also need to be 90 millimeters off, so from 0 to 9. There we go. And you see, for this video I'm using a slightly larger contractor, because for drawing fuselages you need somewhat longer straight lines compared to the cross section. So you can use this, it's actually called, I think it's called a protractor. So you can use this or a ruler to help you with this. So now I have the 4 boxes. Hopefully you can see it. So here we have a box for the side view, for the top view, and one for the front view. The next thing I'm going to do is draw the center lines of the various components. I'll start with the front view actually, and it says here that the center of the fuselage is going to be positioned 30 millimeters off of the edge of this box, as well as 30 millimeters off of the top. So my center line, which I indicate with a dashed dotted line, is going to be over here, and over here. So that will function as a reference point. So the center point here will be the center point of my circular fuselage. I'm doing the same thing in the top view. Just drawing the center line there. Make sure it's straight with a dashed dotted line. It needs to be a little bit longer, because I already know that my fuselage is barely going to fit on there. Finally, also in the side view, which is also indicated as 30 millimeters from the top part of that box that you just drew. So there we go. This is a little bit preparatory work, but this will help you later on to position the other components. And it will function as a nice datum line there. All right, there we go. So that's the starting point. Now, in the slides we have, for the design of the top view, we have made a list of actions that you can follow in order to design this top view. So the first thing that I'm going to do now is I'm going to design the top view of the fuselage, and for that I have made some preliminary calculations already that have used the dimensions of the cross section. For example, the outer cross section of this airplane is 3.4 meters. That's stemming from this design here. It's a little bit larger here, so there's a small discrepancy between what yours has drawn and what I've actually computed. But in the drawing, that will come down to basically millimeters. So I'm starting with this 3.4 meters, and I've made some calculations on, for example, what the tail cone length is going to be, the nose cone length is going to be. I've estimated the length of the tail, I've estimated the length of the cabin, the length of the fuselage, and with all of these dimensions, I can start drawing the top view of the airplane. Now, I'm starting with the length of the fuselage, which is 30 meters, and I'm starting about 1 centimeters away from that beginning of that box. I'm starting there, and then I'm measuring out 30 centimeters. So this protractor gives me 22 plus 8. That gives me exactly on the border. So maybe that might not be so handy if I have to draw a vertical tail in later on. So let me just decide to start exactly here at the edge of this box. That would give me the end of the fuselage here and the starting of the fuselage exactly here on the edge of this box. Now the next thing, so I'm sort of marking that for myself, beginning and end, but I'm not really drawing anything in yet. The next thing I'm going to do is I'm looking at the length of the tail cone. The length of the tail cone says here is 10.3 meters, and we are drawing everything at a scale, I didn't say that yet, at a scale of 1 to 100. It's a very convenient scale. That means every meter is a centimeter on my drawing. So 10.3 meters comes down to 10.3 centimeters. That's somewhere over here. I'm marking that off here. And now I'm rotating my protractor 90 degrees, and I want to draw 2 points which represent the diameter of the fuselage. So the outer diameter was 3.4 meters. Dividing that by 2 gives me 1.7 meters for the radius and 1.7 centimeters to draw. So I got a mark here, and I've got a mark there. Those are my first 2 points through which I need to draw my fuselage. I'm doing the same thing on the front side. So I look at my nose cone length. It's 5.1 meters. Brings me over here, rotating 1.7 centimeters up and down, and that gives me the first part, the straight part of the fuselage barrel. I'm going to be sure that that is correct. That's my first part of the fuselage barrel, which is going to be straight. All right, now to help me out a little bit, to draw this tail cone, I'm making a very thin extension of this line just to make sure that whenever I draw this tail cone, that it's not gonna go out of this bound. Yeah, and that's just to give me a little bit of a guide, because I now need to make a curve all the way up to the rear end of the fuselage. I don't need a protractor for that. So it's gonna look something like this. All right, it's not the most perfect curve, but I can try that again. It doesn't look very symmetric. This takes some practice. Okay. We do the same thing on the front side, but on the front side we know that we make it a little bit more blunt because that's where the cockpit is. Also the lower curve. Yeah. Doesn't necessarily need to be perfect, but just good enough. Still not really happy about what this curve looks like, so I'm gonna sometimes it takes some iterations just to get it right. And also, if you draw it on a table that is horizontal, it might be a little bit easier than on this diagonal table that I'm using. I think this looks better. All right, so now we have the contours of the fuselage, and the next thing is that we're going to do is we're going to draw in the cabin, and for that, use the protractor again. It says here that the tail length is 4.4 meters, which puts the aft pressure bulkhead 4.4 meters out from the tip of the fuselage. Drawing that in, 4.4. That's me here. So aft pressure bulkhead, i.e. the end of the cabin, is located over there. Yeah. Then it says my cabin length is 22.1 meters. Now my protractor is 22. That's very easy. I'm going to add 1 millimeter to that, which puts me over here. So from this point to this point, that's my cabin, and you see part of the cabin is actually in the cone of the tail, which is actually quite normal. Then in terms of the top view, we still need to look at where the flight deck ends, and you have to make a decision on that. Typically, if you have an airplane that is a little bit smaller and only has 2 pilots, the slides actually suggest that you can then use a flight deck which has a length of about 2.5 meters. Yeah? If you design for 3 pilot cockpit, it can be a little bit longer, but I'm deciding here to use 2.5 meters. So 2.5 meters is 2.5 centimeters. That gives me this point here. So my flight deck is now from this point to that point. Yeah. So that basically, for now, finishes the top view. I am going to add a little bit more dimensions in there, just to convey some more information to the person that's evaluating this drawing. But that's fine for now. Right, so we see from this that we have a cabin of 22.1 meters, tail 4.4, cockpit of 2.5 meters. And with that, we've actually already finished the top view of this fuselage. What we can now do is also draw the front view, which is actually quite simple, because so far we have actually assumed a circular fuselage for this design. So in the cross-sectional design, we've used a scale 1 to 25. Here we're using a scale 1 to 100. We are looking at 1.7 meter radius, as I just said. So we are approximately at 1.7 here. And this is the nice thing about this millimeter paper. You can actually draw that in quite nicely. Right, and that should be a circle. I can make that a little bit thicker with my pen, just for visualization purposes. You see, it doesn't need to be perfect, but it needs to be good enough to convey your design. Right, so I've got now my front view, which is not finished yet. We've got the top view, which is also not finished yet, because we're going to put in a few more items later on. But for that, we first have to do the side view. So now let's turn to the design of the side view. For the design of the side view, we use a lot of the same things that we've already done for the top view. So for example, the location of where the tail cone starts, where the nose cone starts, the beginning and the end of the fuselage, we can all take from the top view drawing. That's why here on the slide you can see I've actually put them side by side or above each other. That's the first thing that I want to do. So just copying the nose, which is basically this point here. Again, I'm using the symmetry line here as a starting point. This is the center line, and then my tail was 30 meters, was here. This is actually the end of the fuselage. This is not necessarily the point of the fuselage, which I'm going to address in just a minute. And since we are using a circular fuselage, the height of the side view equals the width of the top view. So that's pretty simple. That was 1.7 centimeters. Right, and then again, using the same logic as above, I can start drawing the Now, let's first focus on that tail cone, because that tail cone in the side view is not going to be symmetric, because the airplane needs to be able to rotate, and if we were to make it symmetric, the lower part of that fuselage would easily touch the runway, meaning that the airplane cannot rotate so much. Or if you ever want to make a stretched version of this airplane, the stretched version would have a harder time rotating. So I'm keeping that already in mind. Of course, you can rotate also a symmetric fuselage, but you would just need a longer landing gear. So for that reason, I'm already in this part of the design taking into account a little bit of upsweep of the fuselage. The symmetric design would be the design which would have the least amount of drag. So that would, from an aerodynamic point of view, be the most beneficial. So rather than deciding to use the point on the center line as the rear part of the fuselage, I'm deciding to move that up about 80 centimeters here and use that as a notional point. Now, just to be clear, you don't necessarily in both the top view and the side view need to converge to a point. Many fuselages actually converge in the top view to a point, but in the side view actually there is a vertical line there. So that's still totally okay. So let me try to make again I'm using a little bit of a help line here just to guide me, because drawing these shapes is sometimes a little bit harder than you think. Let me do a very thin line just to make sure I stay under there. And I need to go from this point all the way to that point, approximately. Okay, so a fuselage with a little bit of upsweep on the rear side. The next part is maybe a little bit more complicated. That's the drawing of the nose shape. So before I do that, I actually want to know where the pilot is going to be, because the pilot's eye, the position of the pilot's eye, is important for designing the windshield and therefore that whole cockpit part. Right, so where the pilot eye resides is also part of the design process. To make it a little bit simple, I assume at this stage that the pilot is going to be sitting at the same level as the passengers in the passenger cabin. So for that, I first need to know where the floor of the passengers is. So you see, I'm leaving that nose cone out for now because I need to draw that a little bit later. I'm first drawing my attention to the passenger floor, and then it is good to take a look at this cross section again and measure what the distance is between the lower part of the cross section and the upper part of the floor, and I already did that, and that is 1.2 meters. So that means in my drawing here, I can draw the floor at a height of 1.2 meters from the lower part of the fuselage. And then let me also, just to make sure that I cut off the floor at the right location, draw in the location of the aft pressure bulkhead. In other words, the end part of the cabin, which ends over here. All right, now I can draw in the floor, because I remember that it was 22.1 meters plus 1 millimeter. So this is the end of my cabin, and then I said I have 2.5 meters for the cockpit, so I add 2.5 meters. All right, so you see I have extended the cabin floor. This is now my flight deck floor, basically, and now I need to position the pilot. Now the pilot is going to be quite close to the front, because the closer he is to the windshield, the smaller the windshield can be for a given over nose angle and upward viewing angle. So, but he cannot be so close that there's no space anymore for his legs and his arms, and also not for the instrumentation. So from this flight deck, I am positioning the pilot about 1 meter behind the beginning of the flight deck to give some space for his legs, and his eye is about 1.2 meters up from the floor when he's sitting in his chair. So I'm going back 1 centimeter here, and then 1.2 centimeters up, puts me approximately there. So the pilot's eye, which I am drawing in here, eye-like icon, is located over here. Now I'm deciding that I want this airplane to, or this pilot to have an over nose angle of 25 degrees. So he needs to be able to look down 25 degrees, and an upward viewing angle of 30 degrees. And that is actually quite a common, those are quite common angles for this type of aircraft. And I should also draw in a so-called line of sight, a horizontal line, just for reference purposes. So 25 degrees down, point here, and 30 degrees up. But these lines need to be long enough to make that cockpit. And you can actually annotate them if you want. The next thing that I need to do is draw that cockpit shape. In order to make my life a little bit easier, I'm already drawing in the windshield. And the windshield, if you want to make it a little bit more simple, the windshield, you can just use a straight line there, because often you actually have in practice a lot of times that the windshields are actually perfectly straight. So I'm drawing in a windshield, and you see the shallower I make the windshield, so the maybe more aerodynamic, the longer my window pane needs to be. And if I make it perfectly straight, I got the smallest window pane, but from an aerodynamic point of view, not great. So I'm choosing something in between that I think looks sort of believable, right, at this stage of the design. So I'm just drawing in this line as the windshield, and that gives me basically 2 points to which to construct the nose cone. And then for the nose, I need to make sure that I draw the nose under this windshield, right? So, but then not longer than this box. So I have a nose shape, I have a windshield. So we have here space for the weather radar, and below the floor we have some volume available where we can store the nose wheel of the nose landing gear, if that turns out to be the right location. So if we have the windshield drawn in side view, we can copy that actually onto the top view. So I'm looking at the start of the windshield, which is basically the start of the cockpit here, and the end of the windshield, which is basically over here. And then I'm going to notionally draw in a cockpit window just to convey to the viewer that is where the cockpit window is going to be. I can do the same here in the side view. Now the next step that we need to do is to draw in the emergency exits. So the first thing to know is how many do we need, and then I look at the number of passengers that are in this design, and it's 105. 105 passengers in this barrel, but I'm thinking a little bit ahead, and I want to sell this airplane maybe to different operators, and maybe I have designed it for 105 passengers, but maybe there's an operator that wants to reduce the seat pitch a little bit and add another row, or maybe even two. So if he does that with a 5 abreast cabin, you easily go to 110, 115 passengers. So in the design of the emergency exits, I'm already taking this expansion a little bit into account. Now I'm looking at this number, 110, 115 passengers for maybe a high density version of this airplane. And then I look at the number and type of emergency exits that exist. And if I go to this number of passengers, I need at least 2 type 1 exits and 1 type 3 exits. A type 3 exit is an over the wing exit, and a type 1 exit is an exit located on the floor. Okay, so I'll start drawing in the type 1 exit at the rear part. So my idea is that I have one large emergency exit at the rear, one large emergency exit at the front, and that the cross aisle between the 2 exits can also be used as part of the galley area that is likely going to be there. Yeah. So a galley is typically about 90 centimeters in width. So if I want to position my doors, I need to be 90 centimeters away from the aft pressure bulkhead that is located over here. So I'm going to go 9 millimeters on my drawing, making a starting point for my type 1 exit over there. Now my type 1 exit measures 24 inches in width. Let me see what that is in centimeters. 60 centimeters in width, and it's 48 inches tall, meaning I'm going to 1 meter 20. Over the wing exit, somewhere in the middle, measures 20 inches wide, which is 50 centimeters, and 36 inches tall, which is 90 centimeters. And this is an over the wing exit, so I'm positioning this thing a little bit higher such that it's easy to go out. And there are some regulations that state how high you can position it such that you can still step out easily out of the fuselage and then step onto the wing. So there's also a distance between the lower side of the exit and the wing surface. We don't have a wing yet. We haven't even decided if this is going to be a high wing or a low wing airplane, but for now I'm penciling in a type 3 exit at a height of 40 centimeters, and later on, if we decide to do things in a little bit different way, we might have to rethink that. But that's the iterative approach that I'm taking. So 50 centimeters wide, somewhere in the middle over the wing, and 90 centimeters tall. Now the last one would be the type 1 exit in the front, but a little bit of interpretation here. Type 1 exit measures 1 meter 20, so it's about this high. So if you want to board and deboard passengers on a regular basis, which you typically do with a commercial airplane like this, 1.20 meters is not that tall. So for the main boarding door, I am deciding to use an oversized version. So what the regulations state is basically the minimum size that you need for safely evacuating everybody. Now I'm taking a sort of a different standpoint, say, well, from a commercial point of view, I'd like a little bit bigger door. So I'm deciding to go for a Type A door, which is considerably larger. It measures 42 inches in width and 72 in height. So 42 inches is 1 meter and 5 centimeters, and the height is 1 meter 80. I'm drawing that in this space. Again, I'm allowing 90 centimeters of initial cabin to be used by the galley. And therefore, I'm only starting over here. So Type A, Type 3, Type 1 door. So 3 different door types on this airplane. Going to the top view, copying the doors in the top view as well. Now, if you want, you can make little circles in those doors because all of them need to have a small window to be able to look through and determine if there's fire outside the airplane, because if there's fire outside the airplane, you should not open that door. Okay. Now what have we done? We've now penciled in the complete side view. We've got the doors, we've got the windshield, copied some of the artifacts in the top view such that it's consistent. Also, you can also do that on the other side if you want. That basically finalizes the top view, the side view, and the front view for now. And we are done with the design of the fuselage at this stage. It is possible that later on, when we add more components, that we need to make some alterations to this design. And that's what you do in this iterative design process. For example, to see if that Type 3 door is located in the right location as an over-the-wing exit. But for now, this is where we leave things.